Welcome to Creature's QuickStart tutorial. In this tutorial, we're going to animate this dinosaur character over here. To start with, we're going to separate out the individual body parts of this dinosaur character and lay it out nicely on screen. This is an example of what it should look like. The upper head, the lower head, the body, the tail, the arm, and the leg have all been separated out into their individual components. Okay, and what you need to do is to save it into a file. And let's get started. Okay, let's get started. So go to Creature, click Create Project. Now click on the Empty Project button. We're going to make a new project. Let us pick a folder and let's call this Project Test. Okay, and now let's pick the image, which is this dinosaur atlas image over here. And click Create. Okay. You notice that the dinosaur body part image has been imported into Creature. If you click on the individual body parts, you notice that a bunch of triangles are now surrounding each body part. This is basically a triangulated mesh that has been constructed automatically for you, and it represents each body part. These body parts look good. Notice their meshes are separated. However, if you click on the torso or the body, you notice that there's a single triangulated mesh surrounding both the tail and the body. That's not exactly what we want. What we want is to have separate triangulated meshes representing the tail and representing the body. So one easy way to solve that is to use the boundary remesh tool over here. Click on that. Okay, zoom in, and what you do is you hold on your mouse and highlight the triangles you want to use for separation. Now what this means is Creature is going to use these highlighted white triangles here as a hint to determine the separation boundary between the body and the tail. So once you've done that, click Remesh, and now click on the individual body parts. There. This looks good now because the body and the tail have now been nicely separated, and now we're ready to rig the creature. Start rigging. Move your mouse over to the meshing button, click on that, and click on rigging, or rig. Okay, welcome to the rigging mode. This is the mode where you add in the different meshes you created in the meshing mode into your rig and put up bones or construct a skeleton for your creature. To get started, click on Add Region. Now you notice the mesh regions that you created in the previous screen are now available. You can single select them to add them individually onto screen, or you can multi-select by holding down the Command key like this and then clicking Add. Okay, so now you see the mesh regions have been added into the scene. Click on each of them individually and drag them into place. You can do different operations on them. If you click on Scale, you can scale the arm down. If you click on Rotate, you can rotate it as well. So let's move these guys into place. Okay, let's add in an extra arm and leg. As you notice, we have a problem. We want this leg and this arm to be the back. In other words, we want to move it into the back of the layers of the other mesh regions. How do we do that? Well, very simple. You go into this panel over here, and you notice there are Move Back and Move Front buttons. So click on those, select the region you care about, like this arm over here, and click Move Back to shift it to the back. Let's do the same thing for this leg. Right. So now we have the mesh regions mostly placed out correctly on screen, and the next thing you should really do is to rename these regions appropriately so it's easier to reference them later for the rig. Okay, we have renamed the regions, we've placed them correctly, and now we're ready to construct the skeleton. We're now ready to create a skeleton and add bones to our creature. To do that, we have to switch to the bone submode, click on bone, okay, and now click on create. Now, to start creating a bone, it's very simple. Move your mouse over. Let's start with the body. Hold down the left mouse button, and drag. That will allow you to create a bone and let go. That's the first bone you created. So do it for the next bone. Now, before we continue, you notice that for the second bone, it was created below the first bone. In other words, it was the child of the parent over here. And if we create the next bone, say for the upper head, you notice that it becomes the child of the previous bone over here. What if you wanted to change the parent of this bone, of the next bone you want to create? It's very simple. You'll click on select and select the parent you care about and then continue creating. There. Okay, so let's do it for the rest of the creature. Right, we've finished creating the bones and now we're ready to weigh the creature or weigh the bone regions. Okay, let's start weighting the bones. What does that actually mean? Well, what that means is we're trying to determine the area of influence that each bone of the skeleton has on the individual body meshes of your creature. So, for example, you could say that this bone here mostly affects the upper head of this dinosaur, and this bone here mostly affects the lower jaw of this dinosaur. That's what we're trying to achieve when we're doing bone weighting. And to get started, you click on the bone you care about and click on weight. Let's switch to the weight submode. Okay, there's a couple of ways to start doing this, but since it's a quick start tutorial, and I'm going to give you the most convenient method to do this very, very quickly. The first thing we need to do before any weighting is to make sure that all these bones over here are assigned to their correct regions. We want the upper head bone to be associated with the upper head mesh. We want the tail bones to be associated with the tail mesh, and so on. There's a couple ways to do it. So the most direct way to do it is to click on this affected regions button. You notice it says all. This means that this bone here is now influencing all the meshes, all the body meshes in this character. Probably not what you want, but it's the default option. So click on all, and now click on, for this case, the upper head, and you say select single. Click on that. This selects this just says that the bone is affecting only the upper head. Now click done, and you notice it's just the upper head. Now to select another bone very easily, switch to another bone for weighting and select and region assignment, just hold on the shift button and click on the bone you care about. That switches over to the other bone. So let's do that again, and we can say lower head, select single, done. Okay, so that works, right? That's basically region assignment per bone for a single bone. What if you wanted to region assign on a group of bones? Now, obviously, you could individually switch to each bone by pressing the shift key and then going to the affected regions and assigning the region. That works, but it's rather tedious. An easier way to do that is to use the group assignment method. And the way you do it, very simple. Hold down on the command button and group select the bones you care about. Okay, in this case, I have all the tail bones selected for region assignment. You notice now this button called Group Region Assign is now enabled. Click on that. And I can very easily select the tail and click Select Single and click Done. And now immediately, if I switch to any of the tail bones, you notice that all of them have been assigned the tail. So let's do this for the rest of the mesh. Okay, you notice that we have assigned all the mesh regions correctly to their corresponding bones. The next thing you need to do is actually apply weighting onto the bones. In other words, we're trying to now determine how much influence each bone has on the region. Now, the most direct and manual way to do this is to directly use the manual weighting mode, and that allows you to use a paintbrush-like method and paint on the region you care about to determine how much influence it has. In this case, you notice the white portions basically say that this part of the region is heavily influenced by this bone. Okay, manual method, you can do whatever you want, but rather tedious. Again, since this is a quick start tutorial, let's do it in a much easier fashion. Let's use the auto weighting mode. Click on auto, right? And all you need to do now is click apply to all. And this will magically apply a weighting to every single bone in using a rather complex algorithm. So let's give that a go. Click apply to all. Okay, you notice that the weights have been nicely distributed. If I switch between different bones, you can see some nice gradient weights applied to each bone in a very smooth fashion. That's auto weighting. We've finished weighting the bones with the regions, and now for the fun part. Let's test out our rig before animation. Easy way to do it, click on test. You notice that the bones can now be selected and moved around. Drag the bones and see how your creature deforms under bone deformation. Looks pretty good. It's always a very good idea in general to do a quick test on your creature rig to see how individual mesh regions respond as your bones move about just before animation, so you can fix any rigging or weighting errors before moving on. Okay, that looks good, and now we're ready to head into animation mode. To do that, move your mouse over to Body Rig and click on Animate to start animation. Welcome to Animate mode. This is the mode where we animate our creature or character rigs created from the Body Rig mode. We're going to start off by doing some traditional FK or forward kinematics animation. This will involve opening and closing the jaws of this creature. Now, let's click on one of the bones. You notice that the lower part of the screen has been populated with some text and interesting UI symbols, and the lower right of the screen is also populated with some text and data. This spreadsheet view on the lower part of the screen is basically the keys or knots view, and it shows you basically how the animation data varies over a timeline. The right-hand side of the screen shows you the same data, but only for the current time. In other words, you can look at the values that are set associated with the current time of the animation or the current frame. You also notice that it says FK Motor 3 and motor type FK Motor. Before we begin animation, I'd like to talk a bit about the procedural motor system of Creature. Creature is quite unlike any other animation package you probably have used. In Creature, there is something called a motor. A motor is basically an entity that performs a specific task on a single bone or a set of bones. And it can be a very simple task like FK or forward kinematic to something more complex like IK or something even fancier like a physics rope action. But for now, let's do something simple. Let's open and close the jaws. So drag the handles up and open the jaw. Now step forward a couple frames and close the jaw. You notice that a red line has been drawn for the knots whose values we've set. In this case, we've been rotating the jaw, so the angle has been set, and the red line extends all the way to the other keyframe. And if we click on them, we can easily introspect the values that we set at each keyframe. Now let's play back the animation. There you go. Let's do that again. Let's make the jaw open twice over the entire duration of the animation. Okay, let's play back the animation. Great, so now we have an opening and closing of the jaw. Now by default, every single character rig you bring into the animate mode by default has the FK motor is already installed, so you can go in and literally just animate it in the traditional sense. However, Creature can do things that are much more complex than that, and much easier too. So let's do a walk cycle with the two legs of this creature. What if we wanted to animate this leg in a walking motion? The first thing you're going to tell me is, it'd be great if we could install some kind of IK control onto the 3 bones of this leg. And in Creature, you can do exactly just that. Let's select the 3 bones of this leg. Now click Install Motor. And if you select IK Motor, now when you click on one of the bones, it says IK Motor. This means an IK motor has been installed on this bone. And if you drag the handles, you notice that it's already doing IK on the leg. And as you can guess, you can go in and animate this in an IK fashion in this semicircular motion to get some kind of walk cycle. But that's still kind of tedious because you're still going to be setting keyframes all over the place. Can we do better than that? Of course we can. That is the true power of procedural motors in Creature. So is there a motor that does IK but also at the same time sort of traces out some kind of semicircular walk cycle type arc? Let's select these 3 bones again. And let's install a smooth IK rotate motor. Now you notice a guide in a semicircular form has appeared. Now if we play back this animation, you notice that the leg is tracing out that flat semicircular arc. We can change properties on that arc to make it more suitable for a walking motion. So let's just do that. Click on the height attribute and set it to 3. And I'll play it back. So that looks a lot more like our walk cycle, except in a real walk cycle, the leg is actually hitting, say, a flat ground. So the bottom part of the circle is flat and not an actual circular arc. So let's stop the animation, go back, and let's set scale bottom to 0. And now let's play back. As you can see, that looks a lot more like a walking motion. Let's do it for the other leg as well. Install the smooth IK rotate motor. Place it in the right place. Set the right attributes. And let's play it back. Right, we're almost there, but as you can see, the 2 legs aren't exactly moving like a real walk cycle. In a real walk cycle, the 2 legs are moving out of sync, or the technical term out of phase applies. And so we want to make the 2 legs have an out of phase motion. How do we do that? Well, very easily. Go in, select the motor, and change the phase attribute. In this case, I know that a specific value of 1.2 is going to give us the result that we want. If you want to understand how phase, height, scale bottom, and the rest of the attributes affect this motor, please go online and read the in-depth documentation. But for now, let's set 1.2. And then play it back. Now that looks a lot more like a walking cycle. A very interesting thing about what we just did is that, did you notice we just set a single set of key or keyframe not values on the first frame of the animation, and we practically got a walk cycle for free. This is the most powerful aspect of animating in Creature, because when you use procedural motors in your animation, you can very easily get very complex motion with almost a minimal amount of effort. Also remember that these attributes like height, phase, and scale bottom are keyable over time, so you can actually change them and vary them to suit your needs. Okay, enough of walking. Let's change and set other attributes on this creature. Let's make it a floppy tail. Let's make this tail flop up and down over the range of the animation. So let's click on the base tail motor, click on Install Motor, and click on Rotate Cycle Motor. Now I'm going to set the end angle to 30 degrees and the start angle to, say, -5. And I'm also going to make it flop a bit faster, say 2.2. You'll see in a moment what it does. Let's play it back. So look at that. The tail's already rotating up and down. Again, all we did was set values on the first frame of the animation, and the rotate cycle motor took care of the rest. Now, of course, in a real tail animation, the rest of the bones of the tail actually flop up and down dynamically. They twist and turn in very complex ways. Of course, you could go in and manually animate them with FK, but why would you want to do that? We have much more powerful tools at our disposal with Creature. So let's select the 3 bones of this tail, click on Install Motor, and this time we're going to give it a Bend Physics Motor. Now select one of the bones and change the physics mode to motion, because that's what we want. Now play it back. And look at that. We already have a floppy tail motion, a very complex motion, by the way, that responds to the impulses and actions of the base tail, and we got it all for free. Okay, let's make the animation even less boring. In a real walk cycle, the creature actually bounces up and down. There is some kind of bouncy gait associated with it. Right now it's just being flat, and that's not really appealing. So click on the root bone, click on Install Motor, and let's select Move Bounce Motor. It says oscillates bones in X and Y directions. That's probably what we want. Select that motor. Now we don't want the creature to oscillate left and right. We only want it to bounce up and down. So set amp X to 0. And 2 in amp Y might be too much, so let's set it to a much smaller value so it bounces in a more subtle way. And let's up the speed of the bounce. Now play it back. There you go. Now we have a slightly subtle bounce or gait associated with this walk cycle. You can see where this is going. Let's give dynamics to the rest of the creature and call it a day. Let's make the arms floppy as well. So I'm going to give them a Bend Physics Motor and give them the motion property, and let's do it for the other hand. And I'm going to make the body flop up and down. And let's play it back. And there you have it, a very fluid, dynamic, walking dinosaur, accomplished with Creature's procedural motors. Thank you for watching this QuickStart tutorial. Hopefully this was useful for you in creating your first creature animation. Have fun animating.